All right, mathletes. Sorry I couldn't be here today, but we're going to check out 5-6, the quadratic formula. Now, we've been looking at trinomials, parabolas, quadratics, whatever you want to call them, and we've solved by graphing initially, and you can plug this into your calculator or make a table of x's and y's, and you can solve by graphing by looking at the solutions, the roots, whatever you want to call them. So the solutions are the x-intercepts, so 1 and 3. We can see that with our graph, and that's great. So there's an easy way to find some solutions, right? But sometimes two binomials that multiply together to get this trinomial back. So the x and the x squared would multiply together to give you this. The x and the x would multiply together to give you the x squared. The -1 and the -3 multiply together to give you the +3, and you get -3x's and -1 more x, so you get -4x. Cool. And then you would solve from there by saying, all right, well, either this has to be 0, right, or that has to be 0. If this is 0, then x has to be 1, and if this is 0, x has to be 3, right? And so lo and behold, bam, same solutions. Great. Last time we met, we learned to complete the square. And so completing the square with this, you would set this side equal to 0, because we're trying to solve for when x, the y values are 0, and then you would complete the square, trying to make this side a perfect square trinomial. And it's not, because at the moment you got a 3 over there, and so we're going to get rid of that by subtracting 3 from both sides, right? And then we want to find our own c term to make this right side a perfect square trinomial. So you'd cut -4 in half and then square it. You get +4, right? And that's nice because, then we have to, if we added 4 over here, we got to add 4 over here. Cool. And so this side ends up being 1, and this side, we did all that work so we can factor this into x minus 2 squared, right? And we like that because then we can just take the square root of this, both sides, and the square and the square root will cancel out, and you just get the radicand, which is the guts, the stuff inside. Square root of 1 is plus or minus 1, and we took the square root of all the right side, and we just got the radicand, x minus 2, right? And then you get two cases. One, if x is positive, you get 1 is x minus 2. You'd add 2 to both sides, and you'd get x is 3. And then if you had your -1 on this side, on this other case, you'd add 2 to both sides, and you get x is 1, right? Surprise, surprise. It's the same thing we got before. Bam. Cool. So there's a final way. Sometimes the numbers aren't as nice. It's harder to complete the square. So we're going to look at the quadratic equation, and it comes from completing the square. So I'm just going to show you where this quadratic equation comes from, which you've seen before. You don't have to memorize how to get it. I just wanted you to see that it's not magic. It's math-tastic. All right, so we start out with a quadratic equation, ax squared plus bx plus c equals 0. All this a equals 0 says it can't equal 0, because if this a was 0, then you wouldn't have a squared term. You'd just have a linear equation. So you don't really need to pay attention to that. It's a little bit intuitive. So to complete the square, what we wanted to do was first get rid of this c term so we can make our own c term, right? So I guess they divided by 0 first, or divided by a. So they divide everything by a to get the x squared by itself, right? So x squared is by itself, and you have everything else in terms of a. You divide it by 0 by a, and you still get 0. And then you move this c over a term, this last term, you move it to the other side so we can take this term, cut it in half, and square it. So b over a, half of it, is b over 2a, right? It's like multiplying by a half. The 2 in the denominator would just multiply in. And then the c term is going to be that squared, right? And if you added it to this side, you got to add it to that side. Neat? All right. So that's great. It's looking a little ugly, but we did all this work so we can take the left side and factor it into x plus b over 2a squared. And then this side, we just kind of switch this around and drop the squared in here, so we get b squared over 4a squared. And that's all fine and dandy, right? So we just said squared, squared, squared. Squared, squared, squared. Great. All right. Great. So we kept left side. Right side, we said, hey man, wouldn't it be nice if we could have two fractions with common denominators? So this we kept, still here, b squared over 4a squared. But then this side we said, hey, let's have common denominators. What else do we need? Another 4 and an a to multiply into here. Right? And so we said times 4a times 4a, and so you get 4ac on top and 4aa on the bottom, which we call 4a squared. Right? And that's nice because we can plug this thing into one big equation and just say this minus that. Nice? All right. We're getting there. We're getting there. So we did all this work on the left side, so we can just take the square root of this side and the square root of this side. If you take the square root of this side, you just end up with the radicand. And if you take the square root of that side, you take the square root of the top, which is square root of b squared minus 4ac. And if you take the square root of the bottom, you take the square root of 4 is 2, and the square root of a squared is a. And it's plus or minus because we're not sure about the value of that. Well, it's starting to look familiar, and then you just subtract your b over 2a from both sides. So we're subtracting this from here, it cancels out, subtract it from here, and you get negative b over 2a plus or minus root b squared minus 4ac all over 2a. And since happily they have the same denominator, we can just crush them into one big fraction and say, right, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Makes you want to sing the song, doesn't it? Go ahead, go ahead. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, sweet. So let's go back to that original equation and look at how it's used. So it's sitting here. I know that original equation was the quadratic formula that we just did all that work for was this guy. And there's b's and a's and c's, so we have to figure out what's what. Well, I know this a is kind of a hidden 1 in front of here, and the b is a negative 4, and the c is this positive 3. So we're just going to start plugging things in. So here's b, negative b, so this negative negative is this a positive 4. That's where this comes from. Yeah. Plus or minus the square root of b squared, so here's 16, minus 4 times a, so 4 times 1, times 3 times c, right? So that's your 12. And then you subtract, and so this is really just square root of 4. The square root of 4 is plus or minus 2, right? Oh, all over 2a, and 2 times 1 is 2. Right? So you get two cases here where you get 4 plus 2 all over 2. That's one of our x's. So that's 6 divided by 2, so 3. And the other one is 4 minus 2, which is 2 all over 2. So 2 over 2 is 1. And there we go. There's our 2x values that we had before. Right? Now which way should you use? Well, whichever way is the most efficient for that problem. Okay? So there's a little bit of a dilemma here, and that's that you can take the square root of any number at this point, unless it's negative, right? You can't take the square root of a negative number. It's because you can't take two of the same thing and get a negative answer, right? 5 squared is 25, and also negative 5 squared is positive 25. So you can't take the square root of a number and get a negative answer. You can't take a square root of a negative number because these are always going to be positive at this point. So all that's saying is you run into trouble when the stuff under the square root, called the radicand, is negative. And we call that the discriminant, because it discriminates between how many solutions there are. So in this case, if you look at b squared minus 4ac, b squared is what, 25 minus 4 times negative 3 times 2. So this is ends up being 25 plus 24 under the square root. Right? I'm just kind of sticking. This is b squared minus 4ac, the stuff we want to take the square root of, and this is going to be a positive answer, which is nice. We can take the square root of positive answer. It tells us there's going to be two solutions. It doesn't say where. It just tells us that there are going to be two solutions. With this one, if you take a look at this one, if you put in b squared minus 4ac, b squared is 16, so minus 4 times a, which is 1, times c, which is another 4. This is 16 minus 16, and that's 0. And when that pops up, you get one solution. Yeah? And then this, when you try this guy, if you plug in b squared, you get 4 minus 4 times a, which is 2, times c, which is 3, right? So you're going to end up with a negative answer, right? When you try to take the square root of that, you can't. So it tells you that there are no solutions. It never touches the x-axis. It's either above it or it's inverted and below it, right? This guy kind of looks like a little smiley face guy. Neat. So that's called the discriminant. So positive discriminant means positive stuff under the radical, 2 solutions. Negative discriminant, no solutions. 0 discriminant, 1 solution, right? And you're just looking at b squared minus 4ac to do that. It doesn't tell you where, it just tells you how many, right? There's some fancy words for it, but I would like you to just tell me 2 solutions, no solutions, 1 solution. Great. So we're going to have a little quiz over 5.1 and 5 through 5.3. So not completing the square, not quadratic equations, but if you'd like to solve anything using those because you're feeling like a champion, go for it. And after the quiz, you can attack your homework, which is right here. Cool? We'll see you soon. Bye.